Hello and welcome to another video. We're going to be talking about nonlinear and linear systems in this section, and we will start with a little bit of review of a few families of functions. I have 5 different families of functions on the left-hand side of this graph application screen. So the first one we will talk about is f of x equals 2. A reminder that f of x and y are essentially the exact same thing, so try not to let that confuse you along the way here in this video and in future videos. When you see a f of x equaling just a number, that is known as a constant function. So I'm going to write constant right next to it. It is known as a constant function because that y value is not changing at all. It is staying at 2. All constant functions, all members of this family are going to be straight horizontal lines. If you had a straight vertical line, that would not be a function. It would fail what is known as the vertical line test because there are multiple different y's for only one x. Our next family that we're going to be talking about is going to be f of x equaling x minus 30. That is one example of the linear family. Linear is similar to constant. They're both straight lines, but constant is always horizontal lines. Linear can be lines going in any direction, negative or positive, of any steepness or flatness that the equation requires. So these are part of the linear family. Our next function, number 3, is f of x equal to the absolute value of x. You will know its absolute value because it is the only function that looks like this V shape that you see on screen right now. It is kind of recognized by the point of that V shape. That will be kind of the origin point of these sorts of graphs, similar to other graphs that we'll talk about in a second. So these are absolute value. I'm going to abbreviate absolute, just ABS. But I'm going to make it a different color. And those are absolute value. And they can be transformed in different ways, but they'll always have either that right side up or upside down V shape. Our fourth family has a lot of similarities to the one before in that you have a kind of origin point at the bottom here. In this case, it is at -5. But these are parabolas, and they are part of the quadratic family. And we want to write in quadratic here to label this family. And they are all in the shape of parabolas. And they also are symmetric on both sides. And that is a very important fact to remember when it comes to quadratics and parabolas in general. Our last family is one we've just recently discussed, and that is circles. And they're part of the conic section family, and circles are just one category of conic section. So we will write both of those, both conic section and circle. Conic section, and also specifically a circle. And that is just a brief overview of the different families of functions that you might see. And we'll be talking a lot about how these families can be graphed all at the same time. And I could kind of put these two together. And we'll be talking about how to find intersection points and how to find solutions to systems that are belonging to different of members, different families, and all graphed at the same time. And we're going to be doing that using graphing methods and algebraic methods. We're now looking at 3 pictures of some systems that you'd be asked to solve. And they're known as nonlinear systems because the whole thing, both parts of it are not both linear. In earlier years of math class, you might remember solving systems of equations with just lines where they cross at only one place. But now, as you can see in this first example on the left, we have a parabola in blue and a linear function in red, that line right there. And we're looking for the two places it crosses. So if we wanted to point that out, we could show, well, it crosses once at that first orange dot, and then again at the second orange dot. And just by observation, sometimes you can tell what the answers are going to be. Those two answers, you can see where my orange dots are, -1, 1, and 2, 4 are the two answers. And that equations we graph, y equals x squared and y equals x plus 2, we can take those two answers, put the numbers in for x and y to see if they work out. And you can see that work is right beneath our answer here. And we can zoom in a little bit to see a little more closely. So we have all those numbers being plugged in for x and y. And you can see when you get a result like 1 equaling 1 is a true statement. So that means that what we found was correct and our method was correct as well. In the next two examples, we're just looking at parabolas and lines crossing and then two parabolas crossing. So we wanted to kind of point out where they are crossing so we can identify that on future problems. So we have one over here, -2, 0, or 0, -2, I mean, and then 5, 3 would be the two answers there. So we could kind of just write out those two as our answers, and that would be all you'd really be asked to do in this sort of problem. It could be you just looking at the graph itself and finding the two answers for where they are crossing. Intersection points are the solutions to these systems. And so we have those two answers right there. And in the last one, we have just two parabolas and they could be crossing as well. And we could solve these by just looking for where they are crossing. And we have a intersection point at -1, -1, and then one at 1, -1. So we could write out those two coordinate points as our answer for this third example to the right. Now, most problems are going to be a little bit more complicated, and you're going to be asked to graph the actual system. And the main two ways you might be graphing that would be to use a TI calculator, which I'm going to show next, as well as using a website graphing tool, which would be easier in some instances, and some instances may be a little harder.